All right, welcome back. This is a video for problem 9 on homework 5, a little solution. We have a body that looks like a rectangle, and we have a series of 5 forces applied to it, and we want to convert it into one resultant force and a moment acting in. So this is another equivalent systems problem. I always recommend when you're learning this to go to the trouble drawing the equivalent systems, however many there may be. So that's the one that we're given. Call that system 1. This one I'll call system 2. And I'm going to actually simplify things a little bit here in system 2 before I go to system 3. So here's what I'm thinking. I'm thinking that, let's see, I know the sines and cosines of a 30-60 triangle. So I'm going to convert this one into 2.5 newtons downward, and this one into square root of 3 times 2.5 newtons. Okay, and so what I'm doing is just getting rid of this one at an angle and replacing it with its components. This one I like just fine, so I'll keep this one as 6 newtons. This one's fine with me. I'm going to keep this one as 3 newtons. The one up top, so I'm going to break it into its two components, this one and this one. And each one of these is going to be square root of 2 over 2 times 4. Okay, so 2 root 2 newtons. 2 square root of 2 newtons for those two components. And just kind of tidying this up. So now I've got this one. I don't have to worry about this being at an angle anymore. And let's see. I think I'll make that one nice and light. I will need to reference the dimensions, so I don't want to make it too light. And then my final system will look something like this. I'm going to put this one right here, and I'll call this system 3. And that's the one we're asked to solve. So we said we need a single resultant force and a moment at point A. And so what I'm going to do is structure it like this. I'm going to say I need a force component A sub x. I need a force component A sub y. And I need a moment, couple moment here, M sub A. And I want to solve for what those are so that all three of these systems have the same tendency to rotate and to translate. Okay, let's run through our equations. Okay, and this is just a touch for you. That'll work. Okay, so I'll switch over to how about purple ink? And we'll do our summation of the forces in the x direction in system 1 needs to match the summation of forces in the x direction of system 2. In the x direction, I have this, this, and this. Okay, and so I need to define a sign convention. I'll use rightward positive, so root 3 times 2.5 newtons plus 6 newtons minus 2 square root of 2 newtons is equal to my unknown A sub x. I assumed it was rightward, so I'll give that a positive sign. I'm going to skip the punching into calculator if that's okay. You should get A sub x equals 7.50 newtons rightward for that component. Next up, we're going to do summation of forces in the y direction of system 1 matches the summation of forces in the y direction system 2. We'll define upward as positive. In system 1, I have this, and I have this. So I'll do minus 2.5 minus 2 root 2 plus 3 equals, and AY here is pointing upwards, so I'll put that one positive as well. Hey, I'm finishing a video. You're going to be on YouTube. I'll be done in just a minute. You can hang out there. Okay. So once I punch that into my calculator, I will get a sub y equals negative 2.33 newtons. And all that means is that I assume that this is up. So the final answer, 2.33 newtons down. Okay. And I can't remember whether the question asked you for the resultant force or not. So if I wanted to make this into a resultant force, I would just say ax squared plus ay squared, and then take the resultant of that if I wanted to turn that into a single resultant force. I'll leave it in components here just for now. Okay, the final operation is the fun part, so we can do our moments. Okay, so here's the final part of the problem. The summation of moments, and I'm going to pick A, and system 1 matches the summation of moments about A in system 2. I'm doing that because if I have errors on AX or AY, they will not affect my ability to get the correct answer for the moment about A. And now we just have a moment calculation to do. So in system 1, I'll just do one term at a time. So first term, root 3 times 2.5 newtons. That one has a moment arm of 35 millimeters and the sign is negative. Next term, 2.5 newtons. That one has a moment arm of 50 millimeters. Its sign is positive. Next term, 2 root 2 newtons. That one has a moment arm of 50 millimeters and its sign is negative. Next term, we have a different 2 square root of 2. That one has a moment arm of 35 and its sign is positive. Next term, we have 3 newtons. That one has a moment arm of 50 and its sign is positive. And the last term, goodness, this one goes on and on, doesn't it? 6 newtons times a moment arm of 35 millimeters and its sign is positive. And did I get all the terms? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. I'm going to say that I got them all. And on the other side of the equation, I have unknown m sub a, which I'm defining as. Punch all that through your calculator, and I solved this ahead of time, and you're going to get m sub a equals positive 291 newtons times millimeter. And the positive sign validates our assumption that that moment is indeed counterclockwise. Thanks for watching.